Hello friends, myself R.D. Mahajan presenting my one more video on formation of partial differential equation by eliminating arbitrary constant and functions. Let us see the first problem. Form a partial differential equation for z is equals to f of x plus ct and plus g of x minus ct. Therefore, here z is the sum of the two functions f and g, where f and g are functions of two independent variables x and t. C is a constant term. Therefore, to form a partial differential equation, we call this as equation 1. And then differentiating that 1 with respect to x, keeping t constant. Therefore, partial derivative of z with respect to x as dou z by dou x. Differentiation of f is f dash of x plus ct. Chain rule. Differentiation of x with respect to x is 1. Ct is constant, its derivative 0. Plus differentiation of g is g dash of x minus ct. Into chain rule, differentiation of x is 1. Again differentiating, with respect to x, we get second derivative as dou 2z by dou x square is equals to its next derivative is f double dash of x plus ct into its differentiation is 1 plus a differentiation of g dash is g double dash x minus ct. Chain rule. Differentiation of x with respect to x is 1, and we call this as equation number 2. Then second time we differentiate it with respect to with respect to t twice. Therefore, differentiating first time with respect to t, keeping x constant, and therefore differentiation of z with respect to t, f is f dash x plus ct. Chain rule. Differentiation of this term with respect to t, x constant is derivative 0. Differentiation of ct with respect to t is c, plus differentiation of this g is g dash of x minus ct. Chain rule. Differentiation of this term is minus c. We can take c common from this. We get f dash of x plus ct minus g dash of x minus ct. Again differentiating with respect to t. Again differentiating with respect to t. We get next derivative as dou 2z by dou t square is equals to, c is a constant term outside. Differentiation of f dash is f double dash of x plus ct, and derivative of this term with respect to t is c, minus differentiation of g dash is g double dash of x minus ct. Chain rule. Differentiation of this term with respect to t is minus c, and therefore we can take c once again common. Therefore it becomes c square f double dash of x plus ct minus minus plus g double dash of x minus ct. we call as equation 3. Therefore, we have two equations, equation 2 for dou 2z by dou x square and second dou 2z by dou t square. Therefore, using equation 2 and 3, this f double dash plus g double dash, we can replace it by dou 2z by dou x square. Therefore, using equation 2 and equation 3, we get this dou 2z by dou t square is equals to c square, and this term f double dash plus g double dash is nothing but dou 2z by dou x square. As the required answer of a required partial differential equation. Second, form a partial differential equation for function z is equals to a product of two functions f of x into g of y. And as this z is a function of two independent variable x and y, we can differentiate it with respect to x as well as with respect to y. Therefore, differentiating one with respect to x, keeping y constant, we get derivative of z as dou z by dou x. As gy is constant term, I can take it outside, and into differentiation of fx is f dash of x. This dou z by dou x is nothing but p. Therefore, we get p is equals to g of y into f dash of x as equation 2. Similarly, we can differentiate it with respect to y. Therefore, differentiating 1 with respect to y, this time we keep x constant or consider that term as constant term. Therefore, derivative of z with respect to y is dou z by dou y. This time fx is constant term. Differentiation of g is g dash of y, but dou z by dou y is nothing but q. We get q is equal to fx g dash of y as equation 3. Then differentiating this equation 3, differentiating q with respect to x, we get therefore differentiating this with respect to x, we get that term as dou 2z by dou x dou y is equals to differentiation of this product with respect to x, where that g dash of y is constant term, we take outside, and differentiation of f is f dash of x. Then multiplying by z on both sides, we get z into dou 2z by dou x dou y is equals to z q dash y into f dash of x. In this last step, we substitute the value of z as fx into gy. We get is equals to z, but z is nothing but f of x into g of y multiplied by f dash of x into g dash of y. We try to rewrite this gy into f dash of x as first term, and second term as into remaining term. Remaining terms are f of x into g dash of y. This g of y into f dash of x, g of y into f dash of x is p, therefore that becomes p small. F of x into g dash of y, f of x into g dash of y is q, and this left hand side it is z. Dou 2z by dou x dou y is nothing but s. Therefore we get that differential equation as z into s is equals to p. Therefore we get that partial differential equation as z into s small is equals to p small into q. Or in terms of that partial differential coefficient, it is z. S means dou 2z by dou x dou y is equals to p. P is dou z by dou x. Q means dou z by dou y as the required partial differential equation. Or last problem, form a partial differential equation for function z is equals to f of y by x. As it is a function of two independent variables x and y, we can differentiate it with respect to x and with respect to y. Therefore, differentiating first with respect to x, we get dou z by dou x as derivative of f is f dash. Chain rule, differentiation of y by x with respect to x, where y is constant term we take outside, and derivative of 1 by x is minus 1 by x square. Therefore it becomes minus y by x square. Multiplying by x square we get x square into dou z by dou x is equals to minus y f dash of y by x. This dou z by dou x is p, therefore it is p into x square is equals to minus y f dash of y by x. We call that as equation 2. Then differentiating 1 with respect to y, keeping x constant. Therefore, derivative of z with respect to y, dou z by dou y. Differentiation of f is f dash of y by x. Chain rule, differentiation of this term y by x with respect to y, where 1 by x is constant term outside and derivative of y is 1, we get that derivative as 1 by x. Multiplying by x, we get x into dou z by dou y is equals to f dash of y by x. Equation, but dou z by dou y is nothing but q, and therefore it is q into x is equals to f dash of y by x. We call this equation 3. Using this f dash of y by x as qx in equation 2, we get p into x square is equals to minus y f dash of y by x, but f dash of y by x is qx. 1 x cancel, we get px is equals to minus qy. It implies px plus qy is equals to 0 as the required differential equation or required partial differential equation. P means dou z by dou x, therefore it is x dou z by dou x plus qy, but q is nothing but dou z by dou y into y as the required answer. Therefore, here also I have discussed three simple examples how we can form a partial differential equation with the help of given function. In my next video, I will discuss how we can form a partial differential equation by direct integration. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you.